Hey, good evening, everyone. All right. How's everyone doing this evening? All right. So we are going to attempt the essentials of compilation in Gleam. A couple things about this that are worth noting. I don't really know a lot about functional programming. I've written a little bit of OCaml, and I know no Gleam. I literally picked it up 2 days ago, so we're gonna see how far we get. Um, so we'll pull up gleam.run. All right, let's see. I think let's see how far we get. Also, I saw there was a follow. Thank you very much for the follow. I appreciate it. All right, cool. So, uh, let's see. Abstract syntax trees. Let's see, we can pop that in. Probably zoom in a little bit. Oh, that's too much. There we go. So can we do like 125? Perfect. We use recursive functions to construct and deconstruct ASTs. Nice. Use abstract syntax trees to represent programs. They often need to ask questions such as, for a given part of the program, what kind of language feature is it? What are the subparts? Standard terminology. We define a racket struct. The root. We use standard terminologies. Racket struct for each kind of node. Sorry, two nodes. One for integer constants and one for primitive operations. The following is the struct definition for integer constants. The integer value. We establish the convention that struct names such as int are capitalized to create an AST node for the integer 8. We write int 8. Okay. We say the value a primitive operation node includes an operator symbol op and a list of children. For example, to create an AST that negates the number 8, we define the following. Okay, 0 more children. So this would be like the read operator is this. Instead of using one structure for many different operations, read, plus, and minus, we could have instead defined a struct for each operation as follows. Struct read, add, left, right, negate, value. So many parts of the compiler. Instead of using one structure for many different operations, we could have instead defined a structure for each operation. Okay. Racket provides pattern matching to support these kinds of queries as we see in section 1.3. The concrete syntax of program, even when we actually have in mind, because the concrete syntax is more concise. Recommend that you always think of programs in terms of abstract syntax trees. Dangerous move there. Dangerous move to always go for the abstract syntax tree. Programming language can be thought of as a set of programs. A set is infinite. A context-free grammar. Okay. We write our rules to vary to back in order form. As an example, we describe a small language called lint. This consists of integers and arithmetic operations. The first rule for the abstract syntax of lint describes the instance of int is an expression. Okay. Okay, so this one doesn't use white space. Okay. The name such as expression is non-terminal. Name int is also non-terminal. So is the read operation, which gives an input integer from the user of the program. The third rule receives an input integer from the user of the program. Rule 1.2. Okay, so that looks like this. -8. Primitive -8. Okay, cool. The program structure is defined as follows. Compilers often need to access parts of the ASC node. This is pattern matching. Racket provides the match feature across parts of the value. Okay. Okay. Um, okay, so we write a interpreter, right? 63-bit integers. Let's find its reference manual. The function recognizes whether a recursion for lint. ASC okay. So there's one thing I was okay. All right. So a pattern matching the trees here. Inherently recursive, for example, an expression is often made of smaller expressions. Thus, the natural way to process an entire program is to use a recursive function. Body of the function is matched on the input, followed by a call to the definition of the L interpret lint function is shown in figure 1.4. Okay, so we're defining a expression. We match on E if it's an int. So we pass this into the interpreter here. So we check if it's a plus. The partial evaluation, for example, given the following program. So we have a plus, read, minus, and then numbers. All right, let's see. So, all right, so in Gleam, no, that's not. I think that would be what? Patterns? Yeah. So discard pattern, assignments, number formats. Oh, I know what this is. It's like a tuple, right? I guess it could be a tuple, right? Because we're using strings, so we could say like, but sometimes we want to combine multiple values. Lists, oh, lists are good for when we want to combine one type. Is that really what I want to use here, though? I guess it might be a record. I don't know if that's really. Let's say. All right, let's see. What are we? I don't think a list is really the way to go here. Like, we clearly want something that we can match on, right? I just don't know what the right type would be for this. Because it's like kind of a. Hold on. I know he did this in OCaml, so I'm curious. Okay, so that's going to be lib. So that's building the AST. I guess we need a parser first, yeah. Type T takes a lexer and a token. Make lexer takes a lexer and a token, and it lexes the next one. I feel like I think somewhere I have the interpreter book as well. Let's see. Documents. I do. We'll throw that one over there too. Defining our tokens, some identifiers. So these are like constants. That's not really what I want here. So this is the lexer, which we start here. So I'm just curious. Is letter, is digit, is white space. Read the digits. I guess we could do it like that. Okay. So match string input length greater than 0. Yeah, let's start there. Like, let's see, like, how do we just, like, read in file in Gleam? I'm guessing that's probably... No, that's not what I wanted. I want, like, this standard library. Oh, I just passed it. So how would I, like, open a file in Gleam? Oh, I passed it. Simply file, right? Okay, so let's just start with that. We'll clear this out. This is all my testing from earlier. So this is import simply path. Or simply file. Let input equals what does assert do? I'm guessing it's just like we're saying that where do I don't know anything about assert in this actually. I didn't come across that yet. Is it under panic maybe? Okay. So let's just try that. So write to file, read from file. Okay, so all right, so simply file. Yeah, that's not right. It's that's yeah, it's completely wrong. Read. Okay, so simply file.read, and then I could just do like we know what type this is? String. IO. Ooh, can I chain this? Can I go like yes, that does make sense. We could do data or okay, so that didn't work. Why? Is there something I'm missing here? Let's see. Let's see. How are the tests run? Oh, I bet it's because I did this wrong. Yep, there we go. That'll do it. All right. So we do need to import a package to use it. All right, let's see. So we have all these tokens, so that's going to be like a pattern match. So we need to advance. Okay. Take while, read identifier, read digits, next token, minus. So we're calling advance on the left. We call advance here, which takes the elixir, which is I see. Yeah, I guess we could write tests too. All right, so there we go. So that'll allow us to read it in a file. Cool. All right, so let's just like takes the current position and adds one. Do we have iterators somewhere? So how do you iterate this thing? Gleam iterators. Oh, it's the standard library. So what if we just take this and we say like data or I thought I disabled this. Copilot disable. Okay. All right. So we need some way to iterate through this. Can I just what is an element? Or it doesn't have a type in an accumulator. Good. All right, let's just try this. Data. Um, all right, so can I just so how do I build an iterator from all right, let's see. All right, let's see. String to iterator. Gleam. So let's say non-empty string to its first element and the rest. Interesting. Let's try that. So we just do okay, so we'll import Gleam string. I'm in string, right? Yeah. All right, data. I guess we could do pop string dot All right, so we pass it the string data. Okay. So there's that. Cool. So now we do all right. So we have that there. And then let's do like an io.print line first. Yeah. Where's the lists? What if I just want to get like one list? That index sequences in Gleam, but so how do I just get the first part of a list? Could I just do like first, second? So can I say like first, first, rest? How do you do that? Here. Head and tail. Case splits. So this would be like first, second. Did I do that right? Let's see. Case. So how do I what is that? I'm very confused on how to use this thing. Um, we could probably. Oh, I know where to look for this. Interesting. What's Gleam? Great question. Gleam is a friendly language for building type-safe systems at scale. So it's a functional programming language for the Erlang runtime, but it can also compile to JavaScript. Oh, hello. So yeah, it's basically it compiles to Erlang and also JavaScript, but it's a functional programming language. So it's yeah, I don't know what I'm doing. We're trying to figure out a little bit about Gleam and like kind of just understand how that looks. So it handles encoding, but how about... So what if we did this? So I'm not really sure. Is that a tuple, I guess? That's too much. It's too much right now. Tuples. Where were they? Or tuples. Yeah, there we go. Okay. Now we're cooking. We can go like this. So can I just say like let Ocam Larkin coming? Yeah, pretty much. First, I don't know. I've played around with a little bit of OCaml, and we're using Dylan's kind of OCaml stuff to kind of walk through this, but yeah. Oh, the lighting is all sorts of weird in here. Hold on. I might go turn on the light. There we go. I was realizing that my eyes were just like, you couldn't see them. Okay, so in theory, we should be able to io.print line first. What do you mean it's not in scope? How does that... How is that not in first? Oh, because this can error, right? Yep, it can be an error. Match splits or case. So we have first Expected type string found. How does it make any sense? Hold on. Okay. Returns a result. Is there something I'm not getting here? Exactly like you would with lists. All right, so how would I pattern match on a list? Oh. Yeah, that's what I thought. So what if we just, for the time being, we can just do it like this? IO dot print line. We'll say for this, we can say functional in shambles. Wait, I don't need it at all? Oh, because it's a nil error. That's kind of weird. So that's how we're going to do it. No, so we'll just say like result string nil. Okay. Oh, is that, am I mixing up my languages again? Probably. Let's see. Yep, I totally am. Yeah, so what we'll do is we will just say, let's. Oh, because we're asserting that it's okay. And if it's not, then it wouldn't. So actually, we could say this split error. Like that, I think. Hold on. Okay, maybe there's something I'm missing here. I don't. For the time being, we're going to say this. We'll say assert. Okay. This is going to crash for sure. We're going to just like convert this into a function where we take from. We do that part. Yep. Oh, that is not right at all. And then in this one, we do. So we're going to do io.print line first. So we can do this. And then we'll do So we're just going to do this till it crashes. We'll just see what happens. Oh, yeah. This type, the type of this function return doesn't match the return type. Annotation of this function. Expected type string found nil. That's not nil, though. Is it? Oh, right. I guess what we'd say is just return rest. Or we just say rest. So then to use it, we would just say let assert, or we can just say read data. Well, that didn't work as expected. Oh. Yep. Then we need to call it on the rest. So read. Yep, there we go. That's what I was expecting. Yeah, because when we get to the end, we're out of characters, so we should capture that. Okay. Okay, so how do we work with like results? I know there's some here. Let's try that. I think that will work okay. Okay. Um, oh, okay. Sort of like what's the man got to do for like an if statement around here? Too much. Too little. There we go. Okay, so how do I do a case on a option? Oh, not try. Is that it? Split? Man, this is hard. Results. Okay, here we go. That's what I'm looking for. It's a type of generic with 2 parameters. Okay, so let's look at the generics. How's that not in scope? Expected type this. I'm just kind of confused on like how to use a result. Case okay. It's like Rust. Okay. Oh, yeah, that makes a lot of sense. So then it would be like error like that. And then, oh, like this. Right. Yeah, that's fine. Okay. So okay. Yeah, so we're just kind of exploring, Dylan. We're just kind of walking through it here and just trying to see how far we get. Um and I'm trying to just kind of take in a file, read the characters, and like print them out one at a time. I got there, but I crashed it because I was using this assert. So it got to the end of the stream and it was like, yeah, no, there's nothing left. So then I think if this is the case, I could say first, or we'll just return. We'll do io.println first. Hold on. We need a little block. Like this, and we return read rest. Yeah. And then if we hit an error, we just return from, I think. Yeah. Did I have extra spaces in the end of it? Nope. Oh, maybe I did. Nope. Dude, so why are there extra spaces? So what if I just... So what if we just try this? Like, what if rather than returning... I don't know what those extra spaces are. Oh, I guess it would be like a new line? Like, is it printing the new line? That's fine for right now. All right, so now we can print the individual parts. Cool. Huge win. Huge win. All right, so we're printing out lines now. Cool. And, all right. So how would we keep track of position? Yeah, I was taking a look at it because I was trying to just kind of get the idea of the form, but I'm having a hard time kind of understanding. Like, I get the actual OCaml, like what it's saying, but I'm having a hard time like moving that over into here, like into the whole into Gleam. I think the hardest thing for me on Gleam right now is like the syntax is like readable and it's very familiar because it does kind of read like Rust and Go kind of mixed together. But like also it's very functional and I'm like not my wheelhouse, man. Not what I know how to do. Um okay, so we read through. Okay, so I think that's good enough for right now. So we're reading in the lines or the files. Interesting. I don't have the token type created yet. So I'm gonna start that's where I'm starting. So I'm guessing that's gonna look like let me see. I had the types filled up. Let's see. Oh, what's going on with the LSP? The LSP is like kind of weird. Like it has this like, and they had noted it, I think, but like it does this weird thing where like let's say I type IO, like all of this stuff will pop up, right? But if I like, let's say I go like io dot, it like doesn't have anything. I don't know. I don't know. Have you experienced that too, or is that just me? It could just be me. That's very likely. All right. So we have like a in the case of racket, right? So the token type here. Oh, running in watch mode. Uh, New, and if we do the Gleam watch. Yeah, I kind of I saw that in their chat today, so that's not a huge issue. And they're also a pain to write. Um, Once you figure them out, they're like really cool, but they are a pain. Build. Yeah, nope. Yeah, yeah. Don't get me started on YAML. Let's see. Is it the LSP? No. Maybe they don't. I don't know. That sucks. I'm okay with it right now. That's fine. Okay. So we have. Yeah, it is a nightmare. If anyone tells you that YAML, like, oh, it's just YAML. It's never just YAML. It's of the things that I've had to parse, YAML is the least fun. Because spacing can matter. Okay, so admittedly, parsing YAML is never hard. It's okay, it is kind of hard, but the problem with it is less about the parsing it itself and more about like when you want to do other things on top of it. So like when you do templating in something like YAML, templates are generally like curly brace based templates are not valid YAML. So you have to. So there's a couple different ways you have to do it when you're building an LSP. The one that you can kind of do if you have access to like what the template is, you can evaluate the template in memory and then kind of build it and keep track of where everything is. And then that way you have a structure that says like, hey, this is like all of the parts basically. And then you kind of can reconstruct it that way. The other way you can do it is or one way that I tried. I don't love this, but you just take all the templates and you in memory replace them with spaces and then just don't do anything with them. And then it's most of the time valid YAML. The problem is like what if you have it as a value to a key in the YAML dictionary? Well, that's valid, but if it's like somewhere else, like you might see in Ansible or something, it's not. But yeah, don't. It's tough. It's never the templating part. I think is the hard part. I don't think that YAML is the worst, but it doesn't do you any favors. Okay, so let's do the token type. I'm guessing. So we have. Token. Identifier. Okay, so I would make a separate file like I did and then import it. Okay. Token dot gleam. So all right. So let's say pub type. No, it's not. It's not Rust. Token. So this should be like, okay, Copilot stop. Thank you. um, Oh, warning scenarios and keywords. Oh, that's an Alacrity thing. Yeah. I have Ghosty, but there's a bug in it, and I haven't taken the time to report it yet. Yeah, I'm in. Zelaj is like T-Mux. Okay, so I don't know if I need that. Let's actually. I don't think we need that. Yeah, Alacrity. Okay, so no, Neovim is spell checking, but Alacrity has support to display it. Yeah, it's weird. It's really weird. I at one point had a way. No, I don't. I don't like it. At one point in time I had a way to disable it, and I just haven't. I just haven't gotten to it. Admittedly, it actually wasn't this bad until this. I don't know why. So we could say like number int. Let's see. There you have it, folks. Set no spell. Oh, I know why. Because I do actually like it on like Markdown. So I probably just need to set a. Here, we'll do that real fast. You gonna get me on this? Edit text. Yep, that's the one. Nope, that's not. Okay, thank you. There we go. Oh, I like the wrap too. That's nice. I wouldn't even think to do that. Okay, and then after this, right, I need to also go in and set like, yeah, don't look at that. Don't look at that. I don't know why that one's. We'll talk about that at a different time. And then we would just set vim dot opt dot spell false. Oh no. Put that up here. Oh, there it is. All right, there we go. don't know if that's right. But we want to do the other direction, right? Like we're going to take in. So let's say I did like pub func input. So that's one I'm going to look at. Not sure if that's exactly right. So we're taking the token. I guess we don't really need to do that. We can do like number. Okay, so we have some tokens. If you used a real language like Python, Meta, you're talking to someone whose new gig is going to be working with some Python. Quite a bit of Python actually. And you'll be happy to hear this one. C++. Huh? No, actually. I know. I know. I know. I know. Okay, so what am I missing here? Is this all I need? This is because this is what I'm like inferring here. Oh, thank you for the follow, Leostera. Let's go. It's actually bedtime. There we go. There we go. So I feel like I have like a trinity of functional programming knowledge here now. Because like I have no idea what I'm doing. I'm gonna be honest. I am completely lost. But it's fine. We're getting through it. It's so early here. I wish it were early here, but it is not. You can probably copy the same function signatures. So yeah, that's kind of what I was doing. So where is it? Like this, right? So we have plus, minus, and read. Not the vibes. Name everything constant, unconstant would be good. What does that? What does that even mean? I don't. What does that even mean? Okay, cool. So we have all of the token types, right? Okay, so now shows violence. Here, I'll just do like number snake, left snake, right snake. I've never written Lisp, which probably is, causing me pain right now. I've read it, but I've never written it, so this is great. Okay, so we have a token. Great. So I've heard. Well, we actually know that Meta is a C dev. So let's not get out of here, okay? Like let's not try to sell him short that he's anything more than that. Okay, so we have. Okay, so now we need a Lexer, right? Dylan, why did you put a two string? Is that just so you can print it out? That is a string that. Okay, so But that would be like the Lexer, right? So that would be this, where we take a token, like a string, and return a token. That's fair. Okay, so we'll make a nvim lexer.gleam. Oh, I created these all in the wrong directory. Uh, okay. Oh no. What did he? Oh man, Nightbot is on a rage. Maybe they just need to be sheared. Nice. Okay. So hold on. I need to check. Can I just import? Like, do I need to do anything special to import other files? Yeah, I don't know what's gotten into Nightbot there, but that's wild. I appreciate it. It is appreciated. After this peer pressure from Dylan, I need it. So I appreciate it. Okay, so we have this. So how do I import files in Gleam? Is it externals? No. Import token? Yeah. Okay. So pub func parse. Nope. Let's not use that. Let's use the lex, which takes in a string input string. I think technically we can do this. Oh no, it's this. Huh? Okay, I think I could just do that, right? Okay, let's just do... Okay, great. That's perfect. That's good. By path, import path to file. Right. So there we go. It's in the same directory, so that should be fine. All right, so Lex. What is that? Oh my god. Okay, hold on. All right, let's not get ahead of ourselves, people. Okay, all right. We're gonna need Gleam string. If I had to take a guess, we're gonna pull that up. Is there like it is? Inspect. What is going on right now? It's too much. Type to like that. So I can go. There we go. Okay, so we take an input. So this is so it isn't it every input just going to be a single character, right? That's fair. So we just say like if. No, it's not. We don't have if, right? There's no if in Gleam, right? I understood that correctly because this is functional programming. We don't use if statements. Input. Oh, okay. Into bytes. How do we do that? From Probably 2, right? I don't want a UTF-8 code point. That's not what I want. What? Okay, so I don't want that. Let's see. Join. Have char? I don't know. Bytes. Builder. That's not what I want. String. Can I just like do string 2 byte? Nope, byte size. From UTF-8. Does it not like support like just an ASCII char? Gleam char. Let's see. Oh, it's an Erlang thing. If we wanted to pull an Erlang. What is a grapheme? What is that? I mean, I did use this earlier. Yeah, I did. Wait, but isn't it already just one token? Are we assuming the one token case? Right? Because then we could call it like a string dot. Hey! CM Griffin, thanks for the raid. I appreciate it. Man, we're already timing out Leo. Leo Stara. Hi there. Hello, everyone who's stopping by. We're attempting to write functional programming. We're learning Gleam and trying to see how far we get. I take the input, convert it into a char array, and recursively loop over. Oh. That's what I was thinking, yeah. I have no idea. Let's see. Okay, hold on. Apparently for spamming caps, what? I couldn't tell you. It is just like really aggressive. Let's see. Yeah, we'll just. Can I like untime it? Can I untime him out? Yeah, Nightbot does have 0-2. Chill, yeah. Have we written a burrito, a monad yet? No, not at all. I don't think so. I don't even sure. No, I don't think so. We're not doing anything crazy yet, you know. All right. How do I untime someone out? Untime out. What are we? Oh, Twitch. Unban. Okay. Unban. Leostera. Sorry about that. Sorry about that, Leostera. Finding the mod icons for chat. Then it's just checkmark next to their name. Yeah, I probably should. I will take a look at that. There it is. There we go. All right, so Dylan, you were saying we take the input and we convert it, right? So we say list, or we'll say tokens. Okay, come on, Copilot. Copilot. Input or Let tokens equal string dot to graph. Can anyone tell me what a grapheme is? I have literally. Okay, we're gonna look it up. Let's see. Graphemes. The smallest meaningful contra. Whatever this is. So here. Contratassive unit. Yeah, sure. We'll go with that. That's the whole public interface for that. Yeah, I saw that before. Okay. All right. So we take the input. So this. Am I turn something up here? Immutable lectures again. Hey, no worries. Thanks for stopping by. All right. Two graphemes. Are those two different types? Oh, no, 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 no. What am I doing wrong right now? Okay, hold on. This is right, right? It's going to be represented by binary string. Right, but this isn't a binary string, right? Because it's using the Gleam string or a number. So it's type string, found type string. Oh, because I didn't capitalize this. Doesn't return the type of the function. Okay. Match or case. Oh, let me show you binary strings on that. Understood. Understood. So then I need like an iterator, right? Or should I use like a list operator? I think it's from list. In the beam, I just lex the pattern matching and recursion. Okay, so but okay, so I take the first item, right? And then I pattern match that. Or do I just Okay, so I guess what I'm wondering. So here's my thought. Let me kind of write this out in pseudocode. So we take the first token, take the whole string, pattern match on the first thing. Okay. So we could actually okay, so I found something about this earlier. So we could use this. Hold on. Thanks for the follow. I appreciate it. Okay, so if we have a string, right, we can do pop graphing, right? Which I think this would be better, right? Because it just takes the head element and then the tail, and then we call the recursion on the tail. Is that fair, or does that not apply? Because like, what if I have two digits, like two numbers? Like so here, let me kind of demonstrate what I'm thinking. So we'll say with pattern matching on function headers too. I have no idea what that means. No idea. All right, so case. All right, so here, so let me just so we say, let's split equals okay. So if I give it the input, right, and then we can do case um so just go case string. Oh, like so I can just do like case int or input like this, and then say like I don't know if that's valid. It's probably not valid, but like okay, so I can say like that, right? And say like right? Is that okay? I think I have it here. String patterns. I see. The pattern hello matches. Okay. So let me just make sure I'm like reading this correctly. So this is taking the current character, right? Like this. And we're calling the so this is advanced lexer. Is advanced lexer, is this a function? Or advanced is the function here? Oh, lexer. Okay. We're calling advance with the lexer and minus, right? Yes. Oh, okay. Close. You need to do you need to extract the first character of the whole input and then recurse over the rest. We call advanced lexer, but return a tuple. So like is this so this is like one value and this would be another one? Oh. Where'd it go? Right, so this could like return. Oh, I see. So we're calling this. So that moves the position forward one. And we're returning that and then the token. Okay, but which is what we saw in the. Okay, all right. So was shown there. Bingo. Okay, got it. All right. So then to that point, right? In this case, this is extracting the rest, right? So if I said like this, rest, right? That then I could return a tuple if I wanted to, right? Like saying rest. Or I would call lex on rest, right? And then, but okay, but then the return type would change, right? Because now we're returning a tuple. So it'd be like token token. right? Am I seeing that right? Or no, it's not. It's not. It was like we were looking at up here. So we don't need that anymore. Hold on. I'm cooking. Okay, because now we have here. Hold on. We go to the next one and, oh, we don't need to do that. We don't need to do that at all. We can just return the token, right? No, we do need a way to. Do we? Oh, just the list. Oh, the list of tokens. Right? Am I understanding that correctly? So, like, I would take this. Oh, and then, oh, the rest. Okay. So, like this. Right? And then we could say rest. Or. Is that right? No, that's not right. Just list. So if you make a list of tokens, you're good. Yes, we're turning the head of every iteration of the input into an element and concatenating that to the recursion. I'm a little confused by that one. Oh. A list of tokens, not a tuple. Right. But is it? Oh. I see. I see what you're saying. Okay, so this is a recursively nested tuple, which we don't want, right? We want to return a list of tokens, which in this case, right, would look like if we. So then we would just like. So then so then should this return type be a list of tokens? Instead? Right? So we have that. So if we had like a list, remember, is it just list in Gleam? Okay. Oh, I see. Can I say like list? Is that okay? I say list. That's not how you do it, is it? Okay, so let's just for the time being, we'll say like. Or we could just return an empty list here, right? Like list. An internal loop function. What do you mean by that? So an empty list. I think we need to import the list operations. Import Gleam list. Okay, so the outer an API and recurse inside of it with an anonymous function. Hmm. So what would if I'm understanding this correctly, yeah, I was gonna say I'm like Dylan, you sent me the same thing. Let's see. Take while. Oh, so while there's another one, we just append it. And the this loop here. Yeah, sure. Is it not that? What is the No, I see what you're saying. So, but like, isn't in Gleam though? We don't really have the same kind of looping as we do in OCaml, right? If I remember that correctly, because like, isn't it all recursive? Am I missing it? This recursion? Oh, I think it's is it this? Right. So that's is that what you're thinking there, Leostara? Right. And then like so then the other ones would look like hold on, can I do like this? Can I do Yeah. So how would we test this though? I guess that's my question. Because we'd have to write a couple tests. Hold on, let me do a couple of these. Like we'll just do. I think we can also do. Can we do like multiple subjects? No, that's not what I wanted. Yeah, I guess I don't really want that. We'll do like this. You just call Alexa the string and check the list that comes out. Okay. But Dylan, that would mean that we'd want like we would want a way to convert those, right? Like a two string. We wouldn't do it with an internal loop function. We'd have a separate Lex function that people call that loops. So we have a separate function that we would call So that's handling the looping, right? Is that what you mean? Like the lex function is what's doing the iteration? That just takes the first thing, returns a token to the rest. Token to the rest. Oh, we don't need now. Okay. Okay. I'm jumping the gun. Jumping the gun. So we'll take token. I don't know if that's really needed, but and it'll return a string. Okay, I'll keep that in mind. So it's not matched case token. Shoot. Right, so let's do the other ones first. These, oh no, these aren't the right. These are. Is it? These brackets? I think they're brackets, right? Yeah. Oh no, we have brackets and braces. Nice. Oh no, no, okay. Yeah. Okay, so all right, so oh, we need to have the ints. And this is uh that's the opposite. Oh, how do I convert a int to? Oh, is it just two string? I bet it is. Int dot to string. Int. Boom! I'm a god. Look at that. Boom! Pattern matching. Okay. So then what we can do is we can kind of do a test. We'll just get rid of this for now. And we'll do like just that. And if we do uh lexer dot lex. How do I do this on the lexer? Oh yeah, like that. It is pretty nice. I'm gonna be honest, that's the thing that's drawn me to it, is like it has this weird kind of it to me it reads like Go does. It really reads like Go. Oh shoot. Oh, we can do that. Oh, wait, hold on. I can use the fancy. Oh, yeah. Am I misunderstanding something here? Right? Because this returns a list of tokens. Oh, yeah. So you need to map your list. Yeah. So list.map to string. So this. I see. Lex input into that. Oh, yep. Hmm. Oh, we didn't print it. I'm like, I was about to lose my mind. Right, hold on. So wait. So how would I chain this though, right? Because I'm saying, okay, return a string. Oh, just put the whole thing. Yeah, that's a good point. There we go. I mean, that doesn't really. So like, hold on. This should probably fail if I put in like something that doesn't, right? Like if I put in like a number. Yeah, see, it just stops, right? Because it doesn't. That's a case where it would just return. It just fails. All right, so that's good. That's a good thing. That's really good, actually. Okay, so uh, okay, yeah, that makes a lot of sense, actually. This is I'm starting to see it now. Like I understand how that looks, what this means now. I'm tracking what. Yeah. Okay. Oh, this is really powerful then, because then we don't. It's not just one character. I can like take a whole bunch of them. That is really cool. It still currently break if there's a space though. It's yeah. I think I did like a couple days of Advent of Code No Camel, and like when I did a couple of them, I was like, "This is so cool! Oh my god, I get it!" And then I just like, yeah, life got busy. But I was like, "Oh, that's wild." Okay, so here's the hard one though. So if we have an integer, right? How would that pattern look? Because like Dylan, and I saw on your one, you just did like is digit or is white space. Um, right? But we don't really have that here. Like the first valid character for int, and then a different function. Oh, I see. So we would do like pub func lex, which takes a string, and we'd say this returns an int. Oh. So yeah, that can't be right. No, no, no. It's not. It's not an int. It's a. And it wouldn't be a list of ints, right? Like it would just be. Well, I guess we could, right? Because we have this. Hold on. Hold on. Hold on. I had a thought. So if we go to like Gleam int, right? There's parse, which takes an int. What is the return kind of Lex return? List token. So would it be a list of ints? Right? But then can you just combine them into one int? I guess that's like so here that's the part that I'm kind of like getting hung up on. You need to return tokens, right? Yes. Oh. So it'd be like token. Right here and using in parse. Okay. All right. So Lexints will take the rest and return a list of tokens, right? Which over the string, while in parse gives you okay, while in parse gives you an okay, but keep the string value. Keep the string value. So that's like, so while it's okay, we just push onto, we append it, right? Push the string into a string list and parse the resulting string. Oh. Okay. So okay. So all right. So import Gleam int. Right? So then in this case we say like case int dot parse. Let's see. No, that's okay. That's not right. Yeah, it's not. Because this returns a. The if keyword can be used with expressions to add a guard to a pattern. A guard is an expression that must be evaluated true for a pattern to match. Interesting. In a string list and parse the resulting string. You need that whole string and an accumulator. Oh. So this would be the whole string, right? Like our input. And then the accumulator is a list, right? Like that, right? Because that's where we're pushing the string to. You extract a tar from the whole input. On every iteration, you extract a character from the whole input, put it in the accumulator, and try to parse it. Valid in anyway, and you pull it. Yeah, that makes sense. Okay, so I guess the thing that I'm kind of getting hung up on is like from a non-functional programming construct. The thing that I'm kind of struggling with is like in like a procedural programming standpoint, I would just I I would just like use like a for loop or something, right? But like in this case, we don't have access to that, right? So I think that's kind of the part that like keeps tripping me up is like, okay, how do I build everything recursively rather than relying on doing it? This function is the body of your for loop. Okay, so while yeah, we say okay. No, we parse. Wait. Okay, so you said parse the accumulator though, not parse the input. I guess so. Oh, okay. So we still would use this, right? We would still use a pattern match on the first value, right? And then we'd try If it's a valid value, we push it onto the back of the accumulator, or we append it to the accumulator. If the accumulator has... Okay. All right. Okay, so I see. So step one would be int parse the accumulator. Wait. So are we starting with parsing the accumulator? All right. Yeah. All right. So hold on. Let me just try this. So we say int. But int parse, it takes a list of strings. So we have to concatenate the strings first, right? Like we concatenate the accumulator into one. That's what I thought. Yeah. Okay, the largest possible sequence. Okay, so if that's the case, we take the input, we check if it's like this, right? We go through all of them and we say, okay, 1, 2, 3, 4, 5, 6. So literally we want to parse until we see int parse succeed. Recurse while head tail if head is parsable to an int. I see. So then we can do... So I think then that might be... But head... Will head always be a single character? I don't think so, right? Thanks for the follow. I appreciate it. Because like, so here's what I'm wondering. So just hear me out on this. If I have a... Where's string? Here, right? If I go string and I do a... Nope, not to, from. Pop grapheme, right? Where this one, where I'm saying I pop the first value and then the rest of it gets put on the end, right? That would be like head tail. But oh no, but head is like don't have characters. Right. Right. Yeah. Okay. All right. So I think I'm understanding this a little bit, right? So we would say like we take the input and we parse. We take the first value, we check if it can be parsed. If it can, no, we don't do that. That's not what we do. Because what we're trying to do is we're trying to say, okay, if we check the let's start small. Okay, good point. All right, so I'm guessing case is probably where we want to start, right? Because that's where we started on the last one. And we'll do the same thing, right? So it'd be like 0. Okay, yep, that's it. You are right there. I'm right there with you. So we have 0 and rest, right? And we say, okay, if... Okay, but the if won't work here. We can't do guards on these statements. We can't call functions in guards, right? So int parse. Okay, so we have this. We pass it the... Okay, so we are going to call it with an input. So here's my next question. Do we return the input at the end? So what I mean by that is, because this can't, would this return a token at this point? Or are we going to basically fold it back in here each time? It can return a token, but shouldn't it also be returning? Oh, fair comment of mutual recursion. So Lex calls Lexint, and Lexint calls Lex. But why would I? Okay, so here's my question though. Why would I want to call Lex here? To continue the parsing after. Oh, I see. All right. Okay. So we're saying this. Okay. So we're gonna parse the int. No. Okay. So we have 0. That means we're going to go to for nerds. That might be why I'm having trouble here. I do not like go to at all. Unless I have to. Okay, all right. So, but here's the thing. What is digits? Okay, that's not important. Could I just like do the opposite of that? Anyways, that's not important. Okay, so if I have, wait, yeah, no, that's not what I want. Okay, so all right, let's see how we like work with a list. Lists. Oh, if I append to the list. Okay, so all I do is then I say lex int rest. Oh wait, hold on. I got it. I got it. Hold up. Uh wait. Is that right? Is that how would I append to the list? Oh. Like this? No, that's not right. Because that's prepending it to the list, which I don't want to do. Oh, lists are immutable, meaning they are very efficient to add and remove from the front of the list. We rarely append, we mostly prepend. Whoa. Okay, so then if I want to, if I'm prepending the list, do I then have to like reverse it when I get to the end? That's wild. Holy crap. What? That is wild. Why would I do that? I mean, like, to each their own, but that is really. I guess is it because it's just because of the fact that it's a singly linked list and it's immutable, so like you can't. But like, if it's a singly linked list, couldn't you just append it at the end? Right? Oh, because the state. Oh, right. Because, like, you can't change the state of the list. Oh. Oh, I get it now. Oh, that makes so much sense. That hurts me, but I get it. I understand what that I see. Oh, okay. All right. Okay, so then we just do. Oh, because it's a string. So we just say, like, I'm tracking. Okay. So let's just, like, for the time being. Okay. So I'm just gonna put this here for right now. Okay. All right. All right. Okay. Let's not get ahead of myself. So then we'll do the same for one. Rest. Okay. I'm tracking now. That's very. Oh God, I'm scared. Cotton. I was gonna say 4K. I don't stream in 4K, but let's see. I am actually baffled right now, and it that actually really changes everything that I thought I understood. I actually, yeah, it is a good one. I think it's a good one. Wait, you got ads? Okay, hold on. Oh man, I appreciate the sub though, Leostera. I really do. Boom, problem solved. Problem solved. I really appreciate it. This okay, so here's the thing though. This really explains then why I was having so much trouble with lists before when I was learning OCaml. I didn't understand that. That's a key point to think about there. And it makes sense why you would have why an accumulator would be there. Oh, I get it now. That is wild. Okay. And then we need a case for everything else, right? So we'd say like so for everything else we just say I guess this would be like rest. Right? Was that fair? There are operations, but they are O1 versus the O of N versus O1 of prepending. Don't have. There we go, baby. We're moving and grooving now. Let's go. Okay, cool. So now we have this. Okay, but we still haven't done the actual like. But we haven't done the actual part that's like the conversion, the parsing part, right? Because that happens last. So would we do that here? Like at this part, or do we do that after we match? We're moving and grooving. That's right. That's right. So, okay, so here's my question. So, I guess now we're taking, okay, so we have these lists, right? So this is going to print like 9 up until that. Oh, but we're not checking if it parses, really. I mean, we're manually doing this, right? And I guess what we could say is I'm actually seeing how you could do this with that other one as well. Okay, so we have 0 through 9. We are parsing that, so we call rest with here. And it's like, okay, if I get all the way through, I call this again. But we're never converting it to an integer. The syntax to build a cleaner parser that a space determines the end of a number. So you can collect all characters until a space. Well, not necessarily, right? Because it could be like a plus. That could also be a valid. Dylan, if you're still here, is that because like this, right? That this in this case, the 32 ends with parentheses. So that would be then we can't do it that way. We'd have to say like if we'd say like okay, in this case we want to say that we just say like is you're right. Okay. So then so I have a feeling hmm. Okay, so we're lexing the end here. This is I think that this case is not right yet. You can turn the accumulator into a string as well. And just append things there. I could. I could. Yeah, but that's not very functional of me. And just append things there, and then that. Right. Okay. All right. That's fair. That's a good point. Okay, so if I say that this is just a string, right? I could then do that would change to look like this then, right? It would say like no, see now it's like that, right? And then we're calling that up. Oh, but this is where we could parse it, right? So we can do like an int dot parse here, which returns a list of strings. Is that really what it returns? No. Oh, that's what it's assuming it is. I see. So this is that. Okay, so we append the string here, right? And then we say, but we want to check if the parse is successful, right? So we'd say like, okay, So I guess we could do this. Enjoy. Thanks for all the help. I appreciate it. Oh, I see. I see. I see. Okay. So hold on. I have a thought. I see where I was going wrong here. Okay, so we have the list of strings. We do it here, right? So when we get to a point where there's no longer a number, we because this is going to be like all right. So we have a okay. So if it's a digit, so you just update the Lexer state rather than parsing all at once. Okay. Hey, Milky. My API is just next token. No consumers call that. It advances the Lexer and returns a token. Right. So isn't that like what this is doing? Whereas yours will recurse the entire input and return all of the tokens. Oh. Okay, so like let me just kind of so if I'm understanding you correctly, it would look like this. Sherlock, thanks for the follow. I appreciate it. Okay, so we take a token. Okay, so it's going to take an input and it's the function you highlighted on the right. Yes, this one. Right here, right? No, this one. Right? I have a type Lexer. Okay, Lexer. Where is that type? Okay, so if I'm understanding this correctly, then next token type T up here takes an input, a position, and an optional char. Okay, but we're not going to have this here, right? Or no, we would? Okay, so let me try to like wait, hold on. So okay, this is where I'm getting a little confused. So that's not a type like a Go type, right? Where it's like a struct. Those are like different potential patterns. Like, okay, so let me rephrase this here. So we have this part here is not like okay. Oh, I see. And records are here, like this. Right? So this is like what a record is in Gleam. So then if I wanted to do something and that like is a record with accessors, right? So these are all accessors, right? Like these are here. Like an Erlang record. Yep. Okay, so let me just understand this. So if I want to take like this line, if I want to take this line here, that would look like pub type t, right? With input string. No, it would be like token or state. Is that is this like the same thing? If I'm understanding that correctly? And then okay, so then like if I used it, right? Hmm. Yeah. 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 But then we need the optional character, right? So it'd be like do I need it? How do I get the option type in Gleam? Is that an imported type? Like, do I have to do like oh, Gleam uses results for yeah. So it'd be like result like that. Yep. Okay. So this is the type, right? And then if I guess I could say like this, right? I could say like that. No. State. And then what I could do is I could say so like in your case, right? You're taking all right, so where are we using t? Okay. So all right, we have t here somewhere. Lecture is inferred to be type T. Right. Oh, so we can just do like lexer dot input. Right. Okay, so let me just think about this for a second. So oh, in this case, okay. That's so interesting Very, very fascinating to me. Um, okay, so hold on. Let me go back down here. Right, so we have the read digits. Which takes in the lexer, which is this. Gleam will infer the types the same way. I see. Okay, so we have digits. Yeah, that's what I thought. It does seem similar. Okay, all right. So let me just kind of understand what I'm doing. So like if I wanted to rewrite to use this, right? So then if I did like your next token, right? Or a variation of next token. It would be we take the lexer. Yeah, okay. Okay, so we take the lexer and we return a token. Right? No, this doesn't return at all, right? Or it returns a tuple of the the state of the lexer and a token, right? Am I understanding that correctly? So it'd be like okay. All right. So then if I did this, how would so that would look like all right, yeah, let's see. So we take the or let lexer equals skip white space lexer. And then we're matching on if oh so we can I just like pull out the white space out of a string? Oh, it only does it on both sides. Like it doesn't do it in the middle. I guess that makes sense. Zig does something similar. Okay, so like if I'm understanding this correctly, then what we do is we're gonna take it would look the same. So we say lexer dot char um and we do the same thing like this, right? No, we don't. We don't. Hold on. Yes, we do. Okay. Wait, okay, so okay, advanced does what? Let's see. Advanced takes the current position and increments it. Okay, so then yeah, so I have to write that too, right? So I'd say like and returns a new lexer or new state of the lexer. Oh, okay. So then it would be Lexer. Yep. You're one step ahead of me here. Yep. Oh, that's really interesting actually. I kind of like that syntax. So we just say like that's really I like that a lot. But do we need to update? I mean, aren't we changing all of the fields or are we not changing all of them? String.length. Oh. Right. So hold on. Let me just kind of stick with this. Because I mean, so like in your example here, right? We update every field when we advance. Right? When we do an advance, we say uh we increment the position, we then match on the position if it's greater than or equal to the length of the input, right? So that means that we're at the end of the string. If we are greater than the end of the string, then we say that we're at the end, and then this becomes an error, or this is nil. And then if it's not, then we update the record. Is that fair? Okay. I think that's what it is. So okay, cool. I think the string. Okay, cool. So wait, what does this return? Like, how would I match on true and false? Is it true? Oh, is it bool true? Oh, I see. Yeah, just need to read. Okay, cool. All right, so yeah, okay. Yeah, it's just that I didn't have the capital T. So if this is true, we want to then we're at the end and we say that state Lexer. Yep, hold on. Record updates. Yeah. Okay, cool. So I just say char nil. Yep. Yep, there we go. And then for this one, we just say false state is um so I guess hold on, let me go back to this. My only question is like we're taking the not my only one. I've had plenty. Um so string.get is getting from the taking the input from the position onwards, right? So that's saying like get the position here and return to the end. Or no. This is getting the current character or the next character, right? Because this is setting the position. Oh, so we are. Oh, we are reusing the input. Got it. Okay, understood. Dragon. Do we have a way to do that? Okay, so in this case, it's Lexer here. We'll say position is position. And this is the part that's different. That is the how do we just get a single slice? Yeah. Okay. So then this is because so is yeah, length is just one. What do I think about VLang? I've never tried it. I don't really have an opinion about it. So do I always have to put these like these labels? I think I do, right? Okay. Because the type system will infer it. I guess we're about to find out. Um, hey, thanks for the follow. I appreciate it. At index is position one. Let's just get rid of this for now. Okay, so how do I accept a record as a parameter? Is it I need to know the type? Oh yeah, that's like completely wrong. It's this. Oh yeah, I just totally spelled that wrong. Okay. Okay, so I think I can actually get rid of this. Yep. Yeah. Okay. Can't remember. A result of. Yep. Okay, so this is how we do the advance, right? So we're gonna call this. That just gets us the next state. Look at that. An immutable elixir. I know. So okay, so let me just understand. So every time it's checking, it's going, okay, take the current state, or take the whole input, um, append, increment the position forward. If the position is greater than, if we're past the end of the string, then we're done. Um, okay, yeah, that makes sense. Hmm, interesting. All right. All right, so then for next token, we use that here. Down here. Oh, skip white space. I'm guessing that's probably declared somewhere. Oh, just go forward if it's white space. Okay. We'll come back to that in a second. We'll add the white space parsing later. I think that for right now we'll just do this. Okay, so match. Okay, so next token takes a elixir. Is it? But that was what I was having though, right? Like I was running into. Oh, the character, this part here as state, right? Right. No, I know I don't have to. I was just running into issues here with that, like when I was doing that before. Let's see if it's a little. Yeah. See, like when I do it, when I label the type here, when I didn't label the type, it says like unknown type for record access. In order to access to know, we have to know what the naming of it is. So like a better view of that. So that in this case, I had to. Yeah, I thought so too. So I'm wondering if there's like I'm not passing it right, like I, because that's not right. But is it because this is technically like what is it like yeah, I don't know. Oh, up here, like try this to be state instead. Yeah, it does the same thing, or it's something different. Unknown type, state is not defined or imported. And then if I did here, right, like let's show this. Yeah, so that one was a little confused. That one was a little confusing to me. I think we can return. Can I take a state here? So why are you like storing it and then returning it back here? Like, couldn't you just, or is that just like an OCaml thing? Like, could I do like case? Right, but isn't like if I just returned here, wouldn't that be the same thing? Because we're not doing it immutably, that's not the case, right? I think. Like, because what I'm thinking is like, could I just go? Um, oh yeah. Like, doesn't this return as well? Like, I'm advancing the token and returning the token I just parsed. Right. This is returning it up the chain, right? Like, I don't need to do this. Cool. Cool. All right. So let me just make sure I'm like understanding this. Dylan, I hope you know that this has successfully broken my brain this evening. I am I am not I'm not confused. I'm confused, but like in a good way. Like I'm questioning like a lot of my conceptions on like how things should be structured right now. Oh, I just did it again. Okay, well, yeah, we're gonna finish this up, and I might head to bed. But we're gonna finish this up just because I don't want to come back in the middle. Yeah, I hear you. Okay, I already did that one. Okay, am I miss? What am I missing right now? I have them all. I just need read. Um, but you don't handle here, right? You handle. Yeah, you don't handle that here. You. So consumers that use Elixir will make an empty one with the input position equals 0. Then they'll pass it into that. So that's like if I was going to use it, right? So what's an example of that here? Would that be oh, here. Let advanced parser new token. So here. So this one. So read identifier. So we don't really have take while here either. But okay, so let's look at this one here, right? Read digits, which is what we were just working on. So we take the advanced lexer, lexer.next token, lexer. Oh, so this is I think I see what you're saying. Right, because it's so what if I'm understanding this correctly, right? If we look at like read identifier, it's saying read the lexer, take a lexer and the buffer of characters, which in this case would be like an accumulator. We're gonna keep incrementing the accumulator, or adding to the accumulator while it's a letter, and building that into the lexer. And we return the end of the lexer, right? I see what you're saying. Let advanced lexer, char buffer, and then return values from take file. Oh, take file. Okay, so I'm missing. Okay, everything returns an updated lexer state. Okay, so like if I was going to do, so that's basically kind of like what we did here, right? Where like we're taking a thing and returning an updated state. Now we're just applying that to a larger, thing. So we'll say like, okay, so a consumer of Elixir. Oh, I see what you're saying. Okay. I see what you mean. So a consumer of Elixir would be like a function that takes Elixir. Has. Yeah, that's probably easier. Oh, interesting. Oh, okay. All right, so that's where. Okay, I thought we were selling Elixir. So if we wanted to parse it, we call the next token and we return the Elixir and the token. Okay. Because if we go up here, it has a Lexer and a token, which is just this, a Lexer and a token. Chat, we did it. Let's go, baby. We're finally getting it. It's on the consumer to advance a token or advance the Lexer and get the next token. Oh, okay. So parse expression takes in a token and it peaks the parser. Oh. I get it. Hey, thanks, BG. I appreciate it. I'm assuming it's BG. I still don't get it, but take my sub. Yeah. So let me break it down for you. So I think I got it. So basically, like if you have something that's gonna call a Lexer, right? So in this case, the parser is going to call the Lexer for like, hey, I need a token. When it calls it, it updates the values for the Lexer, but the Lexer itself doesn't update the state. The parser, or in this case, the parser is responsible for updating the state of the Lexer. Is that accurate, Dylan? Am I tracking that? I swear to God, this is like witchcraft. Kind of. The parser type has a Lexer. Right. Oh, so every time it's getting a new Lexer. Only the Lexer module can work with the Lexer. Okay, so all of this stuff in this case, when we say Lexer module, that means the Lexer file here. So it can only do stuff here. So when the parser needs to interact with its Lexer, it uses the Lexer module. The Lexer module has a function called next token that takes a Lexer type. Oh, so you hand it a Lexer and you say, Lexer, give me another token and a new Lexer. Got it. Got it. All right. BG, great question. What is a Lexer? It's basically, if I'm understanding correctly, yeah, turn string input into tokens. Right. Right. So if you have, for example, we can look at Dylan's tests because they're quite good. Yeah. So like it takes the number 69, nice, and converts it into an int token of type, or an int token that has the value 69. And a token is like the smallest character, I guess. Is that accurate? Well, no. Because like it's not necessarily a character, right? Because a token is basically what the smallest. Oh, here, I'll go to definition. I'll show you. Yeah. Like this. Like, so it's like a parentheses, this, read. Like it could be like pub is probably a token, function is a token. It's like the individual parts of your syntax. Yeah. So it's the small parts in it to make up the bigger AST. Yeah. Yeah. Okay. That's enough of that. My mind is shattered. Wow. Oh man. Good stuff. All right. I think it is only fair that we raid Leostera. I'm cooked. I know. You're not going to hear from me for a month now. No, I'm just kidding. You'll probably hear from me later this week. Okay. Raid. I overbaked him. I'm like, just like a cake you left in for, like a cake you left in the oven too long, and you're like not sure if you should eat it or not. All right. I really am, Dylan. Your joke, but it's gonna happen. But all right, everyone. Thanks for stopping by. I appreciate all the help and just everyone hanging out today. Yeah, I really appreciate it, and I look forward to streaming more of this and learning more about it. I think I do like streaming at night better than I do in the morning, so I might try that a little bit more. But yeah, thanks to everyone for stopping by, and give shouts to Leostera when we get over there. Okay. Cool. See you guys. Take it easy.